So we were at resolution of vectors. Now we will do some calculation of scalar product and the vector product, right? And then this will be our last class of vectors, and then we can go ahead with our electric charges and field. Okay. So let me erase this part, right? So you guys noted it down, right, earlier. So let me erase this one, and then we can solve the next questions. So we have to basically remember what is the resolution of vectors, what is the resultant of two vectors when we add them, and then when we subtract them, what is the resultant. So, and then the scalar and the vector product. So these are all the important things that we need to remember, right? So let's say you have some perpendicular vectors, right? Let me recall you guys. So recall this one. So let's say you have two perpendicular vectors, right? Let's say this is 3j and this is 4i, right? So your vector is like this 4i and plus 3j, right? And if I want to calculate the angle, so what would be the angle then? 3 by 4, right? So theta would be tan inverse 3 by 4, right? So you guys remember this. Right, so this is, let's say this is 4 comma 3 point, right? This is the vector, right? So you guys remember this, right?
Yes, sir.
Okay, so based on this, there is one question. Okay, so based on this, we have one question. And from the resultant of the vectors, we already know, right? So if we had, let's say, the resultant was what? This was a square plus b square plus 2ab cos theta, right? And the angle was b sine theta by a plus b cos theta, right? And if your theta was 90 degree, the angle between the two vectors, right? So then the angle, this alpha would be how much? B sine 90 is 1 and cos 90 is 0, so b by a. Right, again, this kind of solution. Okay. Okay,
Yes, sir.
so let's do one problem which is based on this. So let us do. So let us see this question. Right, the magnitude of vectors OA, OB, and OC. Right, so we have three vectors: OA, OB, and OC. Right, and in the given figure are equal. Right, so what is the important information that is given? What is the important information that is given? So the magnitude of vector OA. Let's say magnitude of vector OA is, let's say, A, right? And let the magnitude of OB, right? So magnitude of, let's say, OB is A. Okay, right? Because these are equal. And let's say magnitude of OC. So I should not write A. I should write, let's say, L, right? And magnitude of OC. Okay. So magnitude of all these three vectors are equal, right? So magnitude of OA, OB, and OC. So this is given, right? And the direction of OA plus OB minus OC. So we have to find the angle theta here, right? Theta we have to find. And Yes. So we have to find the direction of this vector, OA plus OB minus OC, right? So to find the direction, we have to first find what is this vector. We have to first find what is OA plus OB minus OC, right? And if we know this vector in some Cartesian form, let's say AXI plus AYJ, right? Let's say this vector is like this. So then we can calculate the angle here. So theta would be simply AY by AX, right? So our goal is to calculate this vector in the form of this, right? And when can we do this? When we break or resolve these vectors in separate universal unit vector form, right? So when we break these vector in universal unit vector, as we did in the previous question, so similarly we did this previous question, right? We broke all the vectors in the Cartesian forms, right? In the universal unit vector form. Then we calculated the resultant, right? So this would be our aim again. Okay, any doubt up to this point?
Yes. No, sir.
So first we have to find OA. So what is OA here? The angle is 30 degree, right? And magnitude is L. So this is in the polar form, right? So we know that the x component would be what? L cos theta I hat, right? The magnitude and the cos component. And then the y component would be what? L sine theta j hat, right? So magnitude is in the form of L and cos theta is how much? 30 degree, right? I hat and then plus L sine 30 j hat, right? So cos 30 is how much? Root 3 by 2, right? And sine 30 is half. So this would be how much? Root 3 L by 2 I hat plus L by 2 J. Right, this is OA. Now we have to find OB. Okay. So OB would be how much? Who's going to tell me? Magnitude is again L, right? Magnitude is again L. So what would be the X component of, right? So let's say this is, yes,
Sir, can I
Sir,
say?
yes. What did you say? So two people simultaneously spoke, right?
sir, these are the questions of motion in a plane.
These are of the vectors, right? So we are,
Okay,
yes.
okay.
So these are vectors, right? We are not
Yes, sir.
talking about the motion, right?
Yes, yes.
Right. So these are only vectors. Okay. So we are talking about the vector component and their how can we resolve them and what would be the resultant and what would be the right. So
Yes.
these will be helpful in what? So let's say Coulomb's law. So in Coulomb's law, you apply superposition principle, right? So let's say you
Yes,
have
sir.
some forces, that they are acting on some angles, right? So then that would be helpful. And similarly, we have, let's say, electric fields, right? So electric field also at the
Vector sum.
superposition, yes, vector sum. So they are, so in electric field, they also in electric field, the superposition principle is used, right? So that would be necessary, right? So that is why we are studying this vector. So from the next classes and so on, we would be studying that electric charges and field. Okay. So this you learned vectors you learned in your 11th class, right? So in this motion in a plane or motion in a what in straight line, right? So you study those vectors. Okay. Yes. So what
Yes.
would be OB here?
L cos 60 I cap
Yes. L cos.
plus
Yes.
L sin 60 J cap.
And that would be minus or plus.
Um,
OB is yes.
oh yeah,
OB.
so it will be minus.
So L sine 60 J, right? So this would be how much? L by
1
2 I hat, right? And this would be
root 3 by 2 L J
right.
cap. Yes.
So this is OB. And lastly, what is OC?
L cos 45 I cap
Yes,
plus.
minus or plus?
So okay, it will be minus because I cap is in the negative direction.
Yes,
So
yes.
minus L cos 45 I cap
Right.
plus L sin 45 J cap.
Right. So this would be L by root 2 I hat and then L
C.
by root 2 J. So we can rationalize this root 2, right? So this would be in the numerator. So this would be minus root 2 L by 2 I hat. And then this would be root 2 L by 2 J hat, right? Now we can find what would be OA plus OB minus OC, right? So
Yes, sir.
now we can calculate, right? So this would be how much? Right. So this would be root 3 by 2 I hat plus L by 2 J hat plus this is L by 2 I hat minus root 3 by 2 J hat and minus of OC, right? So plus and minus of, right? So this would be how much? I, and I. So this would be root 3L plus L plus root 2L by 2, right? I hat. And then this would be how much? Plus L by 2 minus root 3L and minus root 2L. Right, so this would be J hat. Okay, so we have resolved this in the ith and jth form, right? So this is the yth component, right? Let's say AY, and this is the AX component, right? Then we can calculate the theta angle, right? So what would be our theta? This would be simply
Y
AY,
by F X.
right? So this would be L we can take common. So this would be 1 minus root 3 minus root t by 2 and then root 3 plus 1 plus root 2 L by 2. Right. So this would be cancelled. So we are left with what? 1 minus root 3 minus root 2. By we can rearrange this, right? So this would be 1 minus plus. Right. So theta would be how much? 1 minus root 3 minus and right. So this is the angle. Right. So which so the first one. Okay. So this is the right answer. Any doubt up to this point, guys?
No, sir.
Sir,
Okay.
we are calculating tan because of the resultant angle.
Right. Yes.
Resultant.
Because the resultant would be how much? So let's say this is two vectors are perpendicular, right? A and B, right? And if we are calculating the angle, this one from the base, let's say this is theta. Okay, so this would be how much? So this is B, right? From parallelogram's law, this is B and this is A, right? So the angle would be how much? From the Pythagoras theorem or from the triangles property, we can see, right? So this would be B by A,
B by A.
right?
Yes, sir.
Because your vectors are perpendicular when you resolve like this, right? So your ith and jth component, and you can write any vector. Let's say your vector is at point, let's say 5, 7, right? So let's say this is 5 and somewhere this is 7, right? So then you can write this angle or in the polar form, right? You can write the vector in the polar form. So this would be how much? 7 by 5, right? So this was the whole idea. Okay, we resolved this vector in the ith and jth component and then just calculated the angle, right? Right, Siraj?
Yes.
Oh, Shavi. Oh, sorry. Yes, so now let us do this problem, right? Again. So these are just related with what is the addition of vector, what are the subtraction of vectors. So let us do this problem. Okay, let me. So were you guys noting this down? Were any of you? Okay, so where should I put the screen? Where should I put the screen, or did you guys note it down?
Sir, ano?
So,
Yes, so you are noting or you have noted or what should I do? Then we can do this problem, and from the next class, I think that the vector should be over, so then we can do these. Then we can be consistent with the class, right? What is happening in your CBSE course, then we can move ahead from that. Okay. Yes, so did you guys note it down?
Yes.
Okay, let me. Okay, so the next question. Two vectors x and y have equal magnitude, right? Again, they have equal magnitude. The magnitude of x minus y is n times the magnitude of x plus y, right? So the angle between x and y is, okay. Again, you have two vectors x and y, and they have equal magnitude, right? So let's say you have the magnitude of x is, let's say, x, right? And the magnitude of y is again x. So let me write. So x and y magnitude is, let's say, again n. Okay. And the magnitude of x minus y is n times the magnitude of x plus y. So this is the subtraction, right? So this is the subtraction and this is the addition, right? So what is the magnitude of the addition of the vectors? We all know, right? For the addition, what is the magnitude? Yes. So for the addition, this is the magnitude, right? X square plus y square plus 2xy cos theta, right? This is the magnitude. Okay. And for the subtraction, what is the magnitude?
X square plus Y square minus 2xy cos theta.
Right, right. Now in the question, what is given? That the magnitude of x minus y, right? So the magnitude of x minus y is n times, right? N times the magnitude of x plus y. So this is given, right? Now we can use these relations, right? So this would be equal to how much? Right. And then for simplification, we can square on both sides, right? So this would be how much? So right, right, guys.
Yeah, sir.
Okay, so and what is also given that magnitude of x and y are the same, right? So we can write this as L square, and this would be 2L square cos theta, right? And this would be L square plus L square minus 2L square cos theta, right? And we have to find the angle between the x and y, right? So this is the angle between the x and y, right? So
Yes.
this would be how much?
So we'll multiply n square with like every element
Yes,
inside the
yes,
bracket.
yes, yes. We have to solve. We have to take this guy and this guy in one side, right? And all the rest in the other side. So this would be Rn, right? So this is 2L square and again 2L square cos theta, right? And n square 2L square minus 2L square cos theta. So we can take first the 2L square, right? So let's take 2L square common. So this would be 1 plus cos theta, right? And 2L square common and square 1 minus cos theta, right? So this guy cancels. Now we can simplify further. So 1 plus cos theta and then n square minus n square cos theta, right? So we can take n square cos theta in this side, right? So cos theta plus n square cos theta. And this guy comes over here. So this would be n square minus 1. Right. So this would be how much? Cos theta would be 1 plus n square. And this is n square minus 1. So your theta would be, cos theta would be how much? N square minus 1 by 1 plus n square, right? So your theta is cos inverse n square minus 1 plus n square. Right, so this is the answer. Right, guys? So we just simply use the fact that the magnitude is n times the subtraction magnitude, right? Okay, so are you guys noting it down? Yes, yes, Chavez, did you say?
Yes, brother.
Yes?
Can
Oh,
you
yes, yes. Cos theta square. Why would we square cos theta, Tariq? Because the magnitude is not the cos square theta, right? Right, Tariq. So for the addition, this is the magnitude, and for the subtraction, this is the magnitude, right? Okay, Tariq. Any?
Okay.
Yes. So when you guys note it down, please tell me, then we can. So you guys tell me whenever I need to scroll down, then I can scroll down this. Okay. And from the next class onwards, we would be starting that electric charges. So if the first topic would be electric charge and the Coulomb's law, right? And then the second topic would be electric field and electric field lines. So we would be doing the questions based on those topics. So in your CBSE course, did they complete the application of Gauss law up to what? Up to the spheres, hollow sphere and solid sphere? Yes.
Sir, they are in electrostatic electric potential, like second chapter.
Okay, so they are on the second chapter. Okay, so we
Yes.
would be, yes, from the next class onwards, we will be quickly doing this first chapter, right? So I would be consulting Arihant JEE questions, and then some questions from SL Arora, and then some question from Singbage. So these books I will be referring. Yes, so no noted.
Yes, certain.
Okay, yes. So the eighth question is easy, right? The projection of vectors. What is the projection of vectors? So let's say this is, you guys are noting down, right? So let's say this is some vector A, and this is theta, and this is vector B. So the projection of this vector on this. So when we take the cos part, cos component, so this would be here, right? A cos theta, and this would be A sin theta. So the projection of A on B would be what? A cos theta. And from the dot product, this is defined like this. A dot B by B and then B hat. Okay, so this is how the projection on A, projection of vector A on B is defined.
Sir, can you once again repeat this question? What is the meaning of projection?
Yes. So let's say, did you guys note it down first? Because I was just recalling what is.
Yes, sir.
Yes. So what is the projection? Let's say this is some vector, right? And this is making some angle theta with this vector. Okay. So when you take the components, the cos component, so the cos component would be here, right? So this cos component is on this vector, right? This
Yes.
cos component is lying on this vector, right? So this would be called the projection of this A vector on this B, right? So this is how you define the projection. Understood?
Yes, sir.
So mathematically, you can write it this way from the dot product, right? Right. So this is the projection. Okay, so we would be using this relation, and okay, so this was not this question, right? So this was this question, right? This question we solved. So what was the answer? Okay. So you see that you see that in this question we have all the minus sign, right? And we can from here. So from here we can see that if we take the minus from a minus in the outside, right? So cos of minus theta is how much?
Minus cos theta.
So this is odd function or even function? This is even function, right? So this would be cos theta. Right, sine of minus theta is how much? Minus
That is
sine,
minus. Yeah.
right?
Yes, sir.
So if we take minus in the outside, so this would be again, so this value will not change. So this is the correct answer, right? Okay, so this would be the correct answer. Okay, or what we can do is that we can take the minus sign. So because you don't see this option, right? In this question, you don't see this option, right? This option you don't see. So what we can do in here is that in respect of or so we can take this term, right? Which term? So n square theta. So we can take this cos theta in here. Okay. So this would be 1 minus n square, and this would be minus of n square cos theta, and this would be minus of cos theta, right? So this would be how much? 1 minus n square and minus cos theta minus n square minus 1, right? So then this would be your answer. 1 minus n square by minus n square minus 1. Right. So then this would be the correct answer. Right. So minus n square minus 1 and this one. Right. So then this would be the correct answer. Because you don't have this plus 1 in here, in both the sides. Right. So then you can take the minus in this. Okay. Yes, so let us do this next question. Yes, so we have to calculate the projection of this vector, right? Projection of this vector A on this vector B, right? So we know what is the projection of A on B. So this is A dot B by B vector magnitude and then the direction, right? So what would be A dot B? A dot B would be what? This would be 1 plus 1, right? And what is the magnitude of B? This is 1 plus 1, right? And what is B hat? So B hat is vector B divided by root 2, right? So this is I plus J divided by root, right? So this would be how much? 2 by root 2 into I plus J, right? So this would be, this root 2 is 2. So 2 by 2 I plus J, right? So this is simply I plus J. Right. Right, guys. Any doubt in this question? Any doubt in
No,
this?
sir.
Right. So ninth question is kind of similar to what we did.
Sir,
Yes.
this is the formula for projection.
Yes. So this is the formula for the projection. Right.
Okay.
Because your projection will be in which direction? The projection of the B, A on B would be in which direction?
B cap.
B cap, right? So this is the direction of that projection, and this is the magnitude of that projection, right?
Yes.
Okay. Now you see that this question is exactly similar to what this sixth question is, right? But in here, the magnitude of x minus y. So magnitude of x minus y was n times the magnitude of x plus y, right? But for the case of this question, the magnitude of p plus q, right? P plus q is n times the magnitude of p minus q, right? So this we have to follow. Okay, and we again follow the same process, the addition and the subtraction, and then you would be able to reach the answer, right? So you guys do this, take this as your homework, right? And tell me the answer in the next class. Okay. Okay, guys. So this you
Yes.
have to follow. And you also know that the magnitude of P is equals to magnitude of Q. And let's say this is some quantity here. Okay, so this you know. So follow this, and then you would be able to reach what is the angle between P and Q. Right. So this, take it as your homework, take this screenshot, right? So everybody taking this screenshot.
Yes, sir.
Now let us do this problem, and then this class will be okay. So let me. Okay, so if A and B are two vectors satisfying the relation A dot B, so dot product and the cross product, right? So these are equal, right? So what is the dot product of a vector? The magnitude.
Scalar product.
Yes, dot product, scalar product, what is that? So that is AB cos theta,
AB
right?
cos theta.
Right. And what is the vector product or the cross product? The magnitude of,
AB sin theta.
right? AB sine theta. Don't bother about that in cap direction, right? So we are only interested in the magnitude. So the magnitudes are equal, right? So this will be cancelled out, right? So this guy comes here. So this is right. So tan theta is 1, which means that your theta is how much?
1.
Theta is 45, right? Right.
Yes.
So the angle between A and B vectors, you found that this is 45, right? So we have to find then the value of A minus B magnitude. So we already know what is A minus B, right? Magnitude of A minus B is how much? Yes, so this is A square plus B square minus 2AB cos theta, right? So, so this would be how much? A square plus b square, and we know the angle between A and B, right? So this is 45. So this would be how much? Right. So this guy comes over here. So we have, so A minus B would be how much? Right. So which option is correct? This D, right? So this was about this question. Right, you guys please note it down, and then we can do this last problem and then meet on the next class. Right, did you guys note it down? Guys, are you guys noting it down, or did you guys note it, or what?
Still going to finish.
Yes. What about other people?
Noting, sir.
Yes.
Yes, sir. Done.
Yes. So let us do this next question, and so that would be then your vectors would be then over, right? So that is all about that we need to learn about the vectors. Right, and in the future, when we meet with the calculus part, then we can discuss the calculus also. Yes, so in this question, the individual magnitudes are given, right? And this is wrong, so this is A2. Right, because there is no B2 in here, right? So this is 8. Okay, so individual magnitudes are given. The magnitude of A1 is given, magnitude of A2 is given, right? And the magnitude of A1 plus A2 is also given, right? So we have to find the value of this quantity, right? We have to find the value of this quantity. So A1 is given, right? This is 3. And A2 is how much? 5, right? And A1 plus A2 is how much? This is also 5, right? So we can calculate what would be then A1 plus A2 dot A1 plus A2. So this would be how much? So this would be A1. square, right? Plus A1, A2, and then A2 plus A1, right? A2, A1, and then A2 square. Right, so this is A1 plus A2 whole square, right? So A1 square, we know this is 3 square, right? A1, A2, this is a scalar product. So these are commutative, right? So A1 dot A2 would be equal to A2 dot A1. Right, so this would be how much? 2A1 dot A2. Right, and A2 square is 5 square. Right. So A1 plus A2 square, this again is 5 square. This is 3 square. So this guy cancels. So we have 2A1 dot A2. This is how much? Minus of 3 square, right? Minus of 9. Right, so A1 dot A2 would be how much? This would be minus 9 by 2. Right. So from these three information, we calculated what would be A1 dot A2. Right. And now we have to find what is this quantity. Right. So we have to find what is 2A1 plus 3A2 dot 3A1 minus 2A2. Right, this we have to find. So this would be how much? 2, 3 is 6 A1 square. Right, and this one would be 4A1 dot A2. So this is where this quantity was needed. Right. And then you have how much? 9A1 dot A2. Right. And then you have 6A2 square. So this would be how much? 6, 3 square. And 4A1A2 plus 9A1A2 is 5A1A2. Right. Minus of 6. A2 square is how much? So A2 square is 5 square. Right. So this is 9, 5, and then minus 9 by 2. And this is 625. Right. So this would be how much? So, and this is 150 and minus of 45 by 2. So this is minus 22.5. Right. So this would be how much? 271.5. So this is 0.5 and right, minus 118.5. So this is the vector part is done, right? This we needed to learn about the vectors. Okay. And I hope this will be enough for this vector part. Okay. So from the next, yes,
I was having a doubt.
you have a doubt.
Yes, sir. Here, for A1 into A2, why we can directly substitute 3 and 5?
4A1 dot A2.
Yeah, sir. In place of A1 and A2, we can directly substitute 3 and 5, right?
3 and 5. No, because you see, your A1 dot A2 is not equal to A1, A2, right? Right, this is not the case. Dot product, you cannot resolve this as this, right? So let's say you have vector A as 3i plus 4j, right? And vector A2 as 2i plus 3j, right? So then A would be how much? A would be 5, right? And A2 would be how much? This would be root of 4 plus 9, 13, right? And
Yes.
what would be A1 dot A2? So A1 dot A2 would be 3, 6 and 12, right? So this would be 18. So this is not equal to 5 into root 30, right?
Yes.
So A1 dot A2 is not equal to A1 dot A2, right? So yes, so these are not magnitude, these are vector products, right? Vector product meaning the scalar product, right?
Yes.
Okay, so you guys note it down, and then from the next class onwards, we can discuss about electric charges. Right. So where should I put the screen?
This is okay, sir.
No, sorry. Yes.
Sir, can just show the question?
Yes. This was the question. So you can correct this is not B2, this is A2, right?
Yes.
There is a misprint over it. Yes, so please guys revise Coulomb's law, and I will then if they are doing electric potential, so we can do up to electric field and Gauss law we can reach, right? Not electric flux. So up to electric flux, then we can discuss. Okay. So in the next class, up to electric flux, we will do some questions.
Yes.
Yes, so did you guys note it down? Everyone noted?